Good morning, everyone. Welcome to day one of re:Invent in 2021. Very excited to be here. I'm Gokul Raghuraman from PwC, and I'm joined by my colleagues Mrinal and Brian, who will be speaking to you very shortly. Today, the topic that we are going to cover is our journey and our experience, and we wanted to share that with you as to how we worked with ETS to build a payment solution and a seamless experience for ETS's customers. Now, before we get started, just wanted to call out very quickly that while the three of us are here, behind the scenes, obviously, we didn't turn up here by ourselves and build a solution. There was a lot of people who helped us build the solution, both from PwC as well as ETS, so we want to acknowledge that. The topics that we wanted to cover today would be, what are some of the common challenges that you see or that we have seen our customers face, whether it's in the payment space and any other line of business application? What are the challenges that they face today? How does a cloud-native solution architecture help solve some of those challenges? What kind of challenges we faced along the way, our learnings along the way, and how we course-corrected over the period of time, where we started to where we are today. That's in a nutshell what we are going to cover today. Along the next 60 minutes, my colleagues will talk to you about some of the specific considerations that we had put in place as we built the solution, and how we went about operationalizing the solution, and where we are today, and what the future looks like for us. So that said, wanted to open by talking a little bit about what are some of the common challenges that we see that our clients face in the marketplace. This is the four that we've shown here are primarily the most common scenarios that we've seen our clients face, right? They either have a scenario where they wanted to focus on building solutions and deploying them and releasing them at the speed at which you could actually experience in the cloud, the capabilities provided by service providers like AWS. Perhaps they are interested in focusing most of the energy on actually building applications that are either revenue generating, customer facing applications, and not having to worry about managing hardware, managing infrastructure, and leave that to people who are dedicated and who are behind the scenes, who are helping stand up the solution. The other aspect that comes up a lot is there's a lot of change happening in the marketplace. Every company is innovating, and you have a very fixed amount of time to be able to reach the market segment. And that was one of the scenarios that we had at ETS as well. We had we had a time limit imposed on us. We had a very short amount of time. We had a very limited set of resources, and we had to make the best use of it to be able to stand up a solution within a certain amount of time. So we'll talk a little bit about what some of those factors were in detail, but at a high level, these are the common challenges that we face whenever we are trying to stand up a cloud-native solution in the cloud. Now, how does cloud-native architecture help? The founding principles at a highest level are these services are managed. When AWS originally started, there was a lot of platform services. We used that for compute and storage. But eventually now, AWS has a depth and breadth of services that allow you to build solutions very, very quickly and be able to test your hypothesis and then release to the production environment. So that's the beauty of the managed services that are already available there, that we were able to take advantage of for our faster release cycles, to test them, and to be able to scale at the speed and the capacity that you would have normally not been able to. We also, as part of managed services, the one thing that we learned over a period of time and we implemented here was the need to automate right from the get-go. So every sprint, there was not just the application development and testing, but we had the checks and balances in place from a platform as well as from an application perspective to be able to automate most of our pipelines and be able to test them on a sprint-by-sprint basis. What it also allows you to do is to be able to scale at at a rate at which you would typically not been able to if you had gone in with managing your own hardware and software. So we were able to put in the right controls and design patterns in place to be able to scale, to be able to roll back, and we heavily leveraged feature toggles to be able to make the solution flexible and customizable. Now, I wanted to pass it on to Brian, who will talk about ETS's journey on where we are.
Hello, everyone. I'm Brian Hirsch. I'm from ETS. Many of you might know ETS. You may have taken one of our very many tests. We have the Praxis test, the GRE, TOEFL exams. We're also a heavy research company, largest private-based educational research company in the world. And with that comes many challenges. We're all over the world in many, many, many countries. One of the funny things our partners tell us is they work with retail companies and other types of payment, companies that take payments. ETS has presented a very major challenge for them because culturally, our company is diverse, our product is diverse, our tests are diverse, everything is diverse, and that creates an interesting challenge. So you can see here we have 50 million tests that we deliver annually in more than 9,000 locations. And so, one of the challenges we have is keeping up with the marketplace. And in years past, we struggled with those challenges. And so one of the things we did was we set out to reinvent our payment process. And we worked together with PwC to come up with what was just a really amazing experience. And every day that goes on, we experience amazing benefits that are, how can I say, light speed. It's just very good journey. So where were we? ETS had a vendor who was very static in nature. So one of the things that we were limited to was what payment methods did they have? We were basically tied with those, and our lines of business would ask, hey, can we try this payment method, or can we go after this market with these new payments? Because let's say the payments that we're accepting are very US-centric. So how do we get to that global rollout and be able to support people throughout the world? And that was a really tough challenge. Other things we struggled with, we had minimal control over our outages and upgrades. The vendor did whatever they want. We had a hosted solution, but at the end of the day, we had very little control over what was going on. That was all happening, based on what was going on in their data center or how they were handling the maintenance of our application. So ETS had been thinking, how can we get more flexible? How can we take over more control without, having staff of hundreds of people to maintain and support, our global presence around the world and be able to take payments in a real-time fashion? So one of the things we also found was the enhancements. They were costly, and they were very slow to occur. Sometimes we would wait 6 months to a year to get, enhancements to the system. And that wasn't, something that was wasn't happening nicely for our customers. So customers would ask us for different things. And in IT, our customers are our business units. And ETS has different silos of different business units. So each of those business units kind of operates slightly independent of another. So, the TOEFL folks may have different requirements than GRE or teacher licensure within Praxis. So each of these units have different needs. And so we had to find a way to be able to provide that in a more timely fashion. Also, cross-organizational communication. One of the jokes is we're trying to give this presentation and you have PwC and ETS, two highly technical companies trying to coordinate with the AWS folks to put the presentation together. It's basically like rocket science. And imagine trying to communicate all your requirements and your features and your infrastructure needs to a vendor who also has other challenges, right? Just a silly not a silly presentation, but somewhat simplistic presentation that we're trying to give today just illustrates how difficult that type of thing can be. And the system wasn't scalable. So, seasonal challenges present different opportunities for ETS to reach more test takers around the world during certain peaks and troughs. The system wasn't very responsive because it was hosted in a data center and because it was physical infrastructure or hardware or constraints based on a contractual nature. We couldn't just scale up very easily. So those were things we had to premeditate or have discussions with our vendor about those types of things. So these were the things that we were mainly looking for when we were trying to build a system, problems we were trying to solve. And at the same time, with all of this, ETS was going through a technological change. We were basically adapting to the new world, shifting our entire platform onto AWS corporate, just throughout the entire company. Also moving to an agile-based development model. So lot of things happening all at once. Okay, now I'd like to introduce Mrinal.
No, actually, I'll cover
Oh,
this
you're
one.
covering
Yeah,
this one?
I'll
Sorry.
cover this one. No worries.
Oh, sorry.
So I think I'll take a couple of minutes to quickly talk through, before we get into the technical architecture, what were some of the principles or the guiding principles that we used before we designed the solution. AWS has a lot of services, great. You can leverage them. We decided to go with managed services, that was great. But from an architectural standpoint, we had to put in certain principles and building blocks in place so that everybody understands what is the expectation and how we work together as we, like Brian said, there's a global customer base, there's different business units looking for this standardized solution. So we first set about thinking through how are we going to completely re-architect the existing solution. The existing solution was vendor managed. We were building a solution from the ground up, and then we are going to stand up in AWS. So we looked at the payment process as a whole. And we started at all the sub-processes that a payment flow is actually required. So how does the customer come and what kind of payments is the customer looking to do? What kind of products is the customer looking to purchase? And what kind of features and functionalities does a typical payment flow happen? So there's an order processing, there is a payment solution that's happening, there is a reconciliation that happens in the back end, there is a refunds that happen. So there's a number of different flows happen. So we started breaking down everything, that huge monolith, into a sequence of sub-processes. The minute we did that, we were able to identify that a lot of these can actually work independently without having to rely on each other. So that was one of the founding principles that we said. We wanted to make it loosely coupled. We wanted to have fault tolerance by isolation in our environment. So we went with the microservice-based approach. We also wanted to make sure, and the next question, obviously, once you decide on microservices is, what is the medium of communication? How are you going to actually communicate, right? Is it going to be synchronous? Is it going to be asynchronous? What are we going to do? We, based on the flow and the use cases that we had then charted out, we then identified that an event-based mechanism is the best means to be able to implement the end-to-end payment journey without being able to rely on different parts of the same flow. So we went with an event-based approach that again helped us from a fault tolerance perspective. It helped us to be able to manage features independently of each other. We were able to test out different features at different points in time. So that helped the microservice and the event-based architecture set us the foundation for that, right? And when we did this, we actually did almost like a pilot, tested out our hypothesis. We did one payment method, worked great, and then we started pivoting at a larger scale, right? One of the things that we also did when we started out was we clearly had a deadline to hit. There was a need by which we had to have the system up and running. And there was a limited amount of capabilities or resources available in front of us to be able to put that in place. So at the get-go, we worked with the ETS team, the architecture team, and their product team to think cloud native first. right? So leverage the power of what is already available, speed up the process of, setting up your platform, and then very quickly building something on it and then testing on it, right? So we've went with most of, and you will see when Mrinal talks about it, most of our capabilities were based on native capabilities that AWS provided. One of the motivating factors were also to make sure that we keep an eye on operational overhead, and this solution, after it's built, it needs to be managed, it needs to be cared for and fed for. So we wanted to keep that to a bare minimum as well. So that was one of the motivating factors that we looked at when we went cloud native. We also wanted to obviously be in a position where we can very quickly swap features in and out. So we put in a lot of feature toggles that allowed us to do that. So what were some of the key considerations that we looked at when we actually stood up the solution? The feature development, the backlog that came in was great, but we also had to have the foundational set of building blocks in place. This was a payment solution. This was an internet-facing solution, right? So you needed to have the right set of these kind of functional capabilities in place to be able to run this at scale. So as an example, this had PII data, this had PCI data, so our application needed a good means to be able to handle both kinds of information in the application. And you will see in the architecture how some of these services were designed to handle that security focus needs. We also wanted an ability to have support. This being a payment application, you want to be able to provide the vast range of payment options that a customer wants to take advantage of. This might be using a credit card, this might be using PayPal, this might be just calling in and making the payment. So you need to take advantage or provide the user with the most number of options, and you need to make it look seamless in the background for the customer. So we had to put that resilience and those capabilities in place for you to be able to do that. So let's say a customer calls and one of the payment methods is not available. The customer should seamlessly be able to pick another alternate payment method and still be able to go through with this order. This was a global, the customer base was global. Payments and orders would come in from anywhere in the globe, so which means automatically it's not just local currency, you're looking at international currencies as well. So the ability to support those was a big part in how the system was defined by these means of these microservices. We did leverage on, there was a number of, like Brian said, there was the upstream there was maybe about 15 plus applications which would be in a position to take orders and send all this to the downstream application, which is the payment solution, the standardized payment solution. You need a way to handle every single request, every single transaction, take it all the way till the payment, get back the confirmation number, and you still need a way to be able to trace it end to end, right? So observability was a huge factor. The golden signals of observability were put in place. We looked at end-to-end tracing, logging, and monitoring, which we will cover shortly. The other motivating factor as we thought through the solution was the payment solution needs keep changing. There are new innovations in the market, new innovations that keep coming in. And as a company who's providing that or enabling that payment solution for its customers, need to be able to take that in at a very quick pace without a lot of re-architecture that was required in the system. So again, we put in a lot of flexibility, configurability in the environment to make sure that the solution was easily maintainable and it could easily scale in the environment. So to do a deep dive, I'm going to call Mrinal, who was the architect on the solution, to talk us through the key factors and the considerations. Yeah. Thank you.
Thank you, Gokul. Hello, everyone. So, yeah, to explain the architecture, I'll take you through a use case. Let's consider the scenario where the user has filled up all the details, provided all the details, and then clicks on the pay button. What happens then? The call first reaches our system via Akamai, which performs the role of the web application firewall. It hits the API gateway. API gateway uses custom Lambda authorizers because we had to integrate with a homegrown solution from ETS, which manages the tokens. So it essentially, extracts the token from the request, validates against the IDaaS, which is the homegrown solution, and then sees whether it's a valid request or not, and then lets it through. Once it lets it through, it goes to the payment service, which is hosted in ECS Fargate. Now, the payment service has to reach out to a payment gateway, which is an external system or a third-party provided system. To that, it first needs to find out what's the URL and the credentials. Now, URL and all these kind of things are stored in parameter store. Credentials are stored in secrets manager where it's rotated. So it gets from these sources, makes a call to the third-party gateway, get a response, then it does some additional processing. So what it does is it creates an event object. It populates all the requests and response and all the transaction-related details to the event object and puts it into the SQS. And then sends a response back to the user. And user sees what happens to the payment and is redirected to the originating system or whichever system from where the request came. Now, what happens to the event now? You got that event in a queue. We have a data service which listens to this queue. It gets the event, it kind of extracts the request and response messages, puts it into S3, which is one of the which was one of the requirement to archive all the requests and responses for future audits and everything. Then it creates a transaction record in the database. Again, database means that you need to know where the database is, where it comes from, parameter store. Credentials, secrets manager, where it's rotated and everything. Then, again, you're storing data in the database, which needs to be encrypted. How the keys are managed, we have used KMS for managing the keys. So after this transaction processing is done, there are a few more steps. So we need to notify the parent or the upstream system that everything has gone through FEN. So we have to send a post back. So data service puts another message in another queue with all the details like what happened to the transaction, which system needs to be informed and everything. And there is one more system which is listening to the queue. It gets the response. It reads the queue, gets the message, sees that okay, this has to go to some other system, and then sends it. So we have kind of given you an idea like how we had implemented the event-driven system, a loosely coupled set of microservices handling various aspects of payment. There are other use cases also. Like, for example, there are cases where we had to do batch processing. Like, for example, settlement records, which comes at a nightly level for multiple transactions. What we did is we had jobs scheduled using CloudWatch, which will trigger this, trigger the ECS job, which would pick up the file, process it, and then update all the records. So this is the overall architecture, kind of how it solves the payment flow. But there are so many use cases, but this is one representative use case, we would say. Now, this is the design. We would go into a little bit detail, like how this particular design actually addresses the key areas which Gokul talked about. First was availability. As you saw, most of the solutions that we used are AWS managed solutions. And the advantage of that is they come with high availability out of the box. AWS does it by distributing the underlying infrastructure across multiple availability zones. However, there are in certain scenarios or in certain services, there are a little bit of considerations. For example, when you're using Lambda or Fargate, if you are attaching a VPC to your Lambda, you have to ensure that the subnets within the VPC are in multiple availability zone. That only ensures that your functions are distributed in multiple availability zone. But for most of the others, it comes out of the box. You don't have to do a lot of configurations. So that really helps. Another aspect of availability is generally distributing a system across multiple regions. Currently, the system is not designed to do it, but once the enterprise lays out its multi-region strategy, it's very easy to evolve this design to be distributed across multiple regions. Next is security. It's a payment application that is accessed like from worldwide customers, which stores PII data. So security was and is a very, very critical aspect of the entire design. So let's go in layer by layer. So first, API access. How we secured our API access was using API gateway. API gateway, again, there was a little bit of challenge here because we had to integrate with one of a custom solution to validate the token and see whether the incoming requests are valid. For that, we use Lambda authorizers, which kind of integrates with that homegrown solution, which is called IDaaS, and so it will take the token, validate the token against IDaaS, and then forward the request only if it's a valid token. Next was encryption across various levels. So first is encryption for data in transit. We kind of enforced HTTPS at the load balancer as well as at the API gateway level. So that way, that kind of ensured that all the data in transit was encrypted. Moreover, we had one more additional layer of security wherein the request body coming from the incoming systems were encrypted using keys, which was mutually agreed upon between this payment gateway solution and the upstream system. Apart from that, since we are storing PII data, we also had additional requirements of encrypting any data at rest using customer managed keys. How we were managing these keys? We were managing these keys using KMS. And KMS integrates very well with all the solutions that we are using, namely S3, RDS, SQS, Elasticache, Secrets Manager. So all these solutions integrates very well with KMS, and that enabled us to encrypt the data at rest using customer managed keys. Another aspect of it is how we secured the AWS services as such. How did we secure AWS S3 bucket or SQS queue? How we did it was, as the design principle states, that this access should be provided at a very fine granular, at a very low level. So we had individual roles created for each of the tasks that were provisioned, and the access to each of the resources were provided at that particular role level. So the scope of access was limited to the funnel was very small. Moving on to the next, resilience. This was, again, one of our key considerations, and we had to take care of it right from the design level. We did it in two areas, or two angles, I would say. One is loose coupling. How we did that is we ensured that whenever we could use asynchronous communication between the two services, we use that using SQS queues. The advantage of that is if there is a particular system which is at fault or which is facing issues, it gives that time to that system or service to recover without actually affecting the other systems. And the other area was fault isolation. So when we looked at the entire payment solution, we first broke it down into individual processes, the processes which can operate within itself and does not depend on any other processes. And then we created services for that. So what happens is, if one of the processes goes wrong, the other process can still operate. And another thing that we did is we implemented feature toggles, wherein we could dynamically turn on and off feature if there are any issues. So I'll give you an example regarding that. So let's say today we noticed that particular type of transaction, for namesake, let's use PayPal kind of transaction is facing issues today. We have the capability in our system to turn off just the PayPal payment option that will remove the PayPal option even from the UI, and user does not get to see the PayPal option at all. But all other types of payment, like the card and everything, will work absolutely fine. And that gives us the time for our support engineers to go back, look at what's exactly happening wrong in our system, fix it, and then test it, and then again roll it back, and then we turn it on automatically. Turn it on, and the system is back to normal, and there is zero downtime literally. So these two kind of give us the capability to isolate the area of a problem, isolate the restrict the damage, and then recover from it, and then get the system back to normal as fast as we can. Next was scalability. Again, managed services to the rescue here. We are using Fargate and Lambda for most of our computational requirements. And these, in our experience, scale extremely well. So that kind of take care of most of our scaling requirement. However, from our experience, we would strongly recommend performance testing your application. Every application's traffic patterns are different, scaling characteristics are different. So you should really tune your application based on your scaling characteristics and your traffic pattern. AWS provides you all the tools, but it is our responsibility to tune our application to make most of it. Now, when we did performance testing on our application, based on the observations, we did a lot of changes, and that helped us tune our applications better. For example, we changed the CPU and the memory that was provided at the basic task level, ECS task level. We also changed the scaling thresholds based on how the application was, the amount of time it was taking to provision new tasks. We also changed the grace period for a load balancer health check, just to, it does not conflict with the application server startup times. So once we did all that, our application was performing way better, and it was able to handle the kind of loads that ETS was expecting. Apart from that, there is one more advantage of performance testing. We validated that during the peak load, we were not violating any kind of the quotas or any rate limitations that are actually imposed. So you need to test that, because you don't want to face that in your production. So it's better to face that and then either get those rate limitations increased, or tune your application or design your application in a different way. Yeah. Again, it's an enterprise application, so support is a big part of it. And to provide effective support, you need to know exactly what's going on in your system, not only at a infrastructure level, but also at a process level, like what exactly happened to each and every transaction that went through your system. Now, observability generally consists of these three pillars. I'll go one by one through each of them. So first was logging. So our application, our system generated two types of log. One is the application log. Application log is nothing but the record of events that occurred in the system. So it will record something like this event occurred, this was the service that handled it, what's the timestamp, what's the details of the event, what was the outcome, whether it was success or a failure, etc. And these application logs were pumped into Splunk, which kinds of gave us the capability to search the logs, like effectively search the logs. The other type of log that our application generated was the request and the response log. So whatever request and response we sent to our gateway, we logged them in our buckets, in a S3 bucket. Now, the interesting part of it is since it's a request and response, it did have PII data. And moment you are talking about PII data, you have additional set of restrictions that you have to handle, additional set of encryption that you have to handle. So distributing these two types of logs in different sources, or different storage patterns helped us. So using S3, how it helped us is it helped us to enable encryption at rest. That was one of the compliance requirement. It also helped us create separate set of access rules around these kind of logs, because you can create a separate access control for the buckets. And another area where it helps is having the lifecycle policies. It helped us automatically transition the logs to archive based on the business rules that were specified. Second area is metrics. We use Dynatrace as our APM. It's an agent-based solution where we had to install the agents in our containers, and that gives us a lot of visibility, not only in terms of resources, like how your servers are doing, how the application health and everything, but it also lets you trace a request call across multiple services. So, and then obviously it gives you a lot of monitoring capabilities where you can configure alerts based on multiple rules. So the third part is tracing. Now, transaction has got multiple stages that across through the day, I would say. So there are authorization, then there are capture, fraud detect, and then there is settlement, which happens at a different time of the day completely. Now, some of these are direct API to API calls, whereas some of them are happened in the batch process. But to effectively identify what happened in a transaction, you need to be able to pull out all the details corresponding to a transaction. So what we did is, there were two aspects to it again. One thing was, again, Dynatrace, which gave us the ability to trace a request across multiple services. So you see, like, if there was a failure, which service failed, and what was the issue there. Apart from that, we generated the logs in a certain pattern. So we used JSON format to export, create the log entries. And one of the attributes of the log JSON was a tracing ID, which in our case was transaction ID. But all the services, be it the batch processes or be it the APIs, followed this pattern. And now, and all of the logs being in the same source, when you search with a particular transaction ID, you could get all the events that happened in a transaction in one shot, and that would give you complete visibility regarding what happened in a transaction. So yeah, so across these three areas, it covered that, the application was very easy to support, and it was very easy to find what happened to a transaction or wherever the system was failing. Next, another area of key area was maintainability. Like when we talk about maintainability, these are the things that we are concerned about. How easy it is to identify your fault, like where is the problem? Next is how easy it is to introduce the fix into the system, or how easy it is to change the system. If it might be a new feature or it might be fixed, but how easy it is to change the system. And the third is how easy it is to actually do a production release. Like, do you have enough confidence in it? Now, there are a few areas that helped us do that. One was using microservices again. Each service having very isolated or very specific purpose. So whenever you see an issue in production, you know exactly which service is responsible for it and what you will have to change. So your focus is restricted to a very small area, and thereby it's very easy to change. Also, the change that you're doing, you're pretty sure that it's not affecting a lot of areas. You know exactly that which area of the code is getting affected by it. So that kind of reduces the risk of a change in your system. Next was, okay, I've done the change. Now, how do I ensure that it does not have any collateral damage? Like, did it break anything else? For that, all our testing, integration, as well as unit, obviously, but everything was automated. So every time we did a small or a big change, doesn't matter. We ran the entire suite, and having it automated means it was fast, and there was hardly any cost of running it. So now you validate your system, you are okay with the change. Now, but then it's a production release, you're always scared. So having a very effective CI/CD pipeline helps. What CI/CD does is it not only reduces your window, but it also it reduces the chances of any error or manual errors in the process. So you are more confident that, about your releases and what will go into the production. So again, with the combination of all these three areas, what it does is it gives the developer a confidence to do a change, as well as the business to introduce this into production. Now, all this was how it was designed to address all the areas or concerns of ETS. And the question is whether it did or not. I'll let Brian answer that.
Thanks. This is, I'm a talker, so this is now my chance to talk and kind of be a little unencumbered. So I have a love-hate relationship with this project. The love was that it exceeded every expectation. From the standpoint, my mic. Yeah. So sorry, love-hate relationship with this project because number one, we were under extreme duress. Our vendor came to us, gave us 15 months. We had already been planning to do a long-term investment and get off the platform, but we had a very short period of time. So what I'll say is extreme exuberation when this past June, we went live with our payment system, thanks to our partners, PwC, and my great team, and everybody at ETS that supported us. But the thing is, it would not have been possible with technology that was not available to us. The AWS platform really made it possible. I currently operate 6 different environments, which I can freely unencumber. It's a little bit costly from an overhead, time perspective, like when we're doing releases. But the thing is, I've done 20 releases since June. We do a release every sprint into production. It's very quick. We do all of our feature refinements, do our bug fixing, whatever we have, and then every release goes out like clockwork. Pretty much 2 weeks, you can set your watch to it. So through automation, through everything that's been talked about, it's unimaginable as to what we can do. It's also unimaginable in terms of what we've talked about, having features being able to be turned on and turned off. When we went live, we thought the big bang was going to be great. This is where I talk about love-hate, right? The exuberance of going live in June was a huge weight off the shoulders. I manage the application. I have a team. We were all very excited, only to find out not everything is perfect. We're trying to make that transparent to our customers, trying to make that transparent to our accounting department. We're trying to make that transparent to our management, right, and how we handle things. Everything that we talked about from an example standpoint, that's not just talk, that what they're presenting in terms of their architecture. All of that actually came true. So our cycle times were cut down from our ability to bug fix. We can turn off a problematic payment method when our partner has an issue like the authorizations aren't happening properly or the fraud detection engine isn't quite tweaked properly. We can easily go in and turn off these features. I can turn off these features. I can't stress enough. ETS has 15 maybe internal payment or internal order systems to handle each of these test registrations distinctly. So it's like having 15 different partnerships. Then I have external companies who do work on behalf of ETS that connect to us. So, I'm effectively a service provider, and I'm providing all of this service every 2 weeks, releasing production. Customers don't know. We do our deployments. The microservice bleeds out or the container bleeds out, and then the next one comes up and start handling the load. So we don't necessarily have to stop, integrate, do all this testing, bless you, with all of the different systems that we have. If I had to stop and do testing, really rigidly with all these different vendors and different payment systems we have, we'd never get anything out the door. And so from an iterative approach and from our environment approach with having all these environments, it allows us to be extremely flexible. Internally, we have we modeled like a mock payment system. So basically, we have our own internal. We don't go out to the vendor. So we can do performance testing. We can do all kinds of different testing on different environments and have different purposes for those types of things. And so with AWS, it's been extremely easy. I can turn off the environments if I need. Right now, I need them all. But I couldn't imagine doing this back in our previous arrangements. We've already processed 1.5 million transactions since we started, which is really incredible. I've had almost no service issues whatsoever. As a matter of fact, this morning, before this presentation, I won't get too much into the detail, but I had like a little flare-up. So Dynatrace sends me a note. I get an instance. I contact my lead developer. We look into the issue. I talk to the product owner. We come to a resolution. We wait 15 minutes. The services are self-resolving, self-healing. We find out there's an issue with our vendor, temporary. But all of that within a matter of a half an hour. It literally took me longer to log and document the incident for the rest of the company than it did to handle and understand, troubleshoot, get to the bottom of it, and make sure that my customers weren't impacted. So that's a reality that is just part of the love of where we are with this system. Earlier they talked about, I'm going to leave some time for questions, but ETS struggled with currency and providing local currency options to customers. So we have a dynamic currency conversion option. So if you have a credit card that's issued in a particular country and you want to use that payment method, and that is going to be in a particular method of currency, instead of having to pay in US currency, we can now dynamically offer almost any currency in the world, which is converted into real time. And so that's a flexibility option we never thought we'd have. The other thing is I talked about adding new payment methods. When we first went live, we had all these payment methods. We went with a big bang. We started them all, and then we realized, oops, this one needs tweaking. We shut it off. We turned it back on. We shut it off. We turned it back on. We had multiple attempts, but we had that flexibility. I didn't need to do releases. One of the things about managing this application, which is really great, is I can have like one service. I can say, oops, break fix. We need to go and identify the payment UI service. We go particularly get that service up and running, or get that container up and running and deal with that. We don't have to deploy the entire application across, its mass. We have, I don't know, probably somewhere between 15 and 20 different services that are running. So I can surgically do whatever I need to do or the team needs to do in order to manage the application. It's a really great thing. And with any system, you want to be able to pay back your investment. So for a lot of different reasons, we're on target to definitely recover our investment within the amortization period that we put together. So that's a positive for ETS. So anytime you want to invest, you always want to make back your money. And I look at our infrastructure, and you'd think like, hey, we got 6 of these different environments that should be costing, like in a data center, it would have cost us, tons and tons of money. And in AWS, our monthly costs are pretty reasonable. So again, that's something we couldn't have planned it better. So I think that's about all I want to cover. So we thank you very much for coming. I appreciate everybody's attention today. Gokul, do you have any final thoughts? I want to open it up for questions. Oops.
So thank you everyone for coming today and listening to our experience and patiently listening to us talk about how we built the system. So Happy to take any questions if you have. We are also available here. We have a booth here for PwC, so happy if you want to stop by there and have some questions, have a chat on the solution, happy to do that as well. So.
I'm just curious, looks like you have Akamai and kind of as your WAF. Is there a reason why you didn't use CloudFront or Amazon Data Center?
Yeah, so I'm happy to answer that. So there are some areas where, like I said, speed to market was very important. There was some existing investments already in play. It was working very well. We didn't want to really boil the ocean. We wanted to make sure that it works because this is not the only solution that is leveraging this. There are other parts of the enterprise which are leveraging that. It all work together. So we wanted to make sure that continues, and we didn't have to worry about that part of the application. Yes.
Yeah, like so one of the things we did, just in an agile manner, I've always had an embedded testing group. So they wrote the tests, they wrote the automated tests. We built that into the pipeline. So each battery of tests is set to run on its particular environment. And as I mentioned, some of those environments connect to the vendors. Some of them are mock. So basically, we've canned responses. So when I have a application system contact me, part of the hate relationship. So I'm effectively managing my own gateway, because if you sent me a transaction for $50, I've got a canned response for that to give you, an accept or a decline. I've given you a card. So I maintain that environment. So I'm able to continuously run that with my partners and let them do that consistently. And internally, we just run those tests all, like every day. There's regression being run. The tester runs it on every environment because they're slightly different. But from that standpoint, it really has not been a hindrance to us. Any other thoughts or more specificity that you wanted?
No, it's really, we're moving into a new major release of our accounting software.
Okay.
It just seems that everyone on us uses real mock integration and everything sets up just breaks down the testing environment. And as we go on the pro,
It takes longer and longer to run.
Sure. Yeah. I get that. We limited the number of tests that we were able to run. So that was one of the reasons why we had the mock system. So there's only X number of scenarios they could run. But it's probably different for an accounting system versus a payment system, because I have X number of card types or a decline, a 3DS. I mean, I'd say there's probably maybe 40 scenarios or so, maybe slightly more. But yeah, the more features you have, the different. But again, if you're in a microservice environment, you're not touching one aspect, you don't necessarily have to worry about the intensive testing there. You can focus.
That's correct.
Exactly.
Yeah.
That's correct.
So one more area that what we did was we used to tag the test cases, and so that would let you run specific test cases corresponding to the release. So not always in all release we would run the entire battery of the tests. So we would focus on the areas where we are touching. So for example, again, if you are touching the credit card, there's not PayPal is not really required to be tested, right? So we had correct tags associated to each test cases, and then during the release we would run only the tags which are relevant to it, not the entire battery.
Yeah. There was another question here, I thought, somewhere.
Yeah, so since you give so many payment transactions, lots of it, so what did you implement to keep everything secure from outside threats?
Yeah, so when Mrinal was talking about the different levels of security, so we have tokens that people need to use. So we have external systems and internal systems that are connecting to us. So each of those needs a unique token. Also, we need to have a valid signing, field signing. So when you send me data, I know we have a mutual understanding of what that hash is. So if you send me data that doesn't match, I'm pretty much not going to accept it, because it doesn't meet the hash requirement as well. And then at each entry point, each touch point, we have all security measures related to the tokens and the handshakes that are happening, plus the encryption across the entire system.
And also, like, your question is like, it's too broad to answer in like one simple
Yeah.
example, but like, any incoming traffic, you had the gateway, you had the firewalls in place to be able to handle that.
Right, and then there's Akamai on the outside, so there's a whole lot of different points. Not one single point of security. That was also key, was to have different varied levels of security. Yeah.
Sure. Yeah.
Yeah, so first of all, ETS and its gateway provider, Fiserv, the reason we chose them was, or one of the implementation methods that we chose with them was to keep our existing PCI level. So ETS does not collect PAN data, credit card data. Our payment vendor does that. And so we get an insecure token that comes back. So it's basically just a number that has nothing to do with the person's credit card data. So I don't have to worry about protecting that because the Fiserv's embedded payment.js, they're the ones who directly take that. They provide me a token value in return, and they handle the credit card part of it. From our standpoint, from PII, personally identifiable information for customers, it's very important to us. So, as these guys talked about, we have KMS encryption on every piece of data at rest. So it's extremely important for ETS to make sure that all of our data is secure in that manner. And so even in our logs, so we don't have any credit card data. And in addition to not storing the credit card data, the customer's personal data is also protected by being encrypted. The only people who have access to view any of that data are people who are vetted within our system, and they have access to those logs through the, we built a back-end management tool. So for example, if I'm doing an order search and I'm looking for your transaction, I go in, I look up your transaction, and if I need to know what happened to that, so there's a layperson's view, but then you can also click on a button right in the transaction, and it'll present the log, which is useful for troubleshooting. So customer service representatives or our internal treasury department can look up that information and get to the bottom of why a customer's payment might have been declined. Because we interpret things from our vendors, like Fiserv, for example, but sometimes you need to look at the raw message to see exactly what happened. So that's the point of why we kept the logs, but it was very important that we have both user level as well as disk level encryption on being able to access those logs. Not anybody can get to them.
Yeah. Yes.
Thank you.
So I'll answer the first question first. No challenges. I mean, like every system, right? There's a level of tuning that needs to happen, which is what Mrunal was talking about. As you start scaling up workloads, as you start doing your testing, there's a level of configuration changes that you'll have to do with. That comes with any service. It's just easier if it's a managed service. The question around ECS versus like an EKS is more directionally where an organization is and what services are allowed services at that point of time when the decision was made. So that was a big part of why we went with ECS. It was not a technical challenge, it was more an operational perspective.
Yeah, at the time, ETS, we didn't have a lot of operational support and knowledge on the IT side to support a lot of Lambda functions, so we mainly went with the ECS. Yep. And it's been great, actually. I can't complain at all.
Cold start? So we did not use Lambda as part of any of our direct synchronous processes. We used Lambda mainly for our backend processes. So cold start was not an issue for us because in the backend processes, even if it's 1 or 2 seconds delayed, it didn't matter to us, whereas ECS Fargate, and that was one of our considerations also. Then that's why we picked and choose where we would use Lambda and where we would use ECS
Yeah.
Fargate.
And I was going to say, like, I'm constantly, as the nervous application manager, I'm constantly saying, is this going to impact, you know, do we have to report a service downtime when we're doing this release? And the bottom line is, nine times out of 10, the answer always came back as no. You know, my engineer is saying, nope, this is going to bleed out. The other container is going to come up, and then you're going to have that capability in production just like that. And it's kind of like a seamless failover. So that was another benefit, I think, to doing that technology versus having the cold start. And just to finish off a stat that I didn't report out, we've had in that 6 months or so, close to 6 months, one planned downtime in that entire time and 20 releases. So only one time did I have to tell all the application systems, you know, we're bleeding out, I need everybody to shut down, and it was because we basically had multiple database infrastructure type things that we needed to do at that time. But that's like a dream come true. It's just been great in that sense.
All right. Thank you very much.
Thank you
again.
very much,
Thank you.
everyone.
Thanks.
We appreciate it.